For problem 9, we are given that x1, x2 to xn is a Markov chain, and it's statistically determined by its second-order probability methods, which is p of xi equals to xi, xj equals to xj for any ij equals to 1 to blah 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 to n. So for this question, we know that since it is a Markov chain, and we can write that the probability of x of tn smaller less than equals than xn, given that x of tn minus 1 equals to xn minus 1, and xtn minus 2 equals to x n minus 2, and 2 xt1 x of t1 equals to xn. So this equation equals to the probability of x of tn smaller and equals than xn, given the condition that xn x of tn minus 1 equals to xn minus 1. So for this part of probability, we can write that the probability of xn equals to xn, given that xn minus 1 equals to xn minus 1, xn minus 2 equals to xn minus 2, and x1 equals to x1 times the probability of xn minus 1 equals to xn minus 1, given that xn minus 2 equals to xn minus 2, and x1 equals to x1, and times so we continue writing this form, and the last two part of this equation is x2 equals to x2 when x1 equals to x1, and times the probability of x1 equals to x1. So we can see that in the first part, only xn minus 1 is related to the probability, and all this rest part, which is xn minus 2 to x1, is not it doesn't affect the result. So we can continue write this equation into this form, which is the probability of xn equals to xn when xn minus 1 equals to xn minus 1 times xn minus 1 equals to xn minus 1 when xn minus 2 equals to xn minus 2, and continue to x1 equals to x1. And since we know that the probability of x1 equals to xi is the sum from the negative infinity to positive infinity of the probability of xi equals to xi and xj equals to k. So the final answer, the probability of xi equals to xi when xi minus 1 equals to xi minus 1 is equals to the probability of xi equals to xi minus 1 equals to xi minus 1 over the probability of xi minus 1 equals to xi minus 1.